Okay, so in example 2, we're going to focus on the property of a parallelogram that opposite sides are congruent. And so as we go, you'll notice I've got some 30, 60, 90 and some sine, cosine, tan thrown in there. So let's start with part A, solve for the variables. I see that y and 4x are equal, but that's not really helpful at this point. So let's go with x and this side being x. In this triangle, looks like we have a 60-degree angle, and across from 60 is 9 square root 3, in which my hypotenuse, if that's the n square root 3 side, should be that number times 2. It should be 18. Aha! So now I have 18 for x, and so 4 times 18 should be what y is, since opposite sides are equal. So 4 times 18 gives us 72 for y. Alright, let's take a look at part B. On this one, we again have opposite sides congruent. I'm getting a little bit ahead of myself here, sorry. Here's your opposite sides congruent, so since that's x, this is x. We have the blue right triangle. We have 6 on the opposite side. We have x on the hypotenuse side, and so we know that we could use sine 50 equals opposite over hypotenuse. And so we could solve this. 6 divided by sine 50 should give us our answer. So approximately 7.8. It didn't tell us what to round to. And then the question is, what is y? And since we know that opposite sides are equal, 7 times 7.8 ... should equal what y is. So we'll go back and multiply our answer times 7, and we get 54.8. So we're going to say y equals 54.8. Okay, I'm going to let you pause the video and you try. Okay, so we used our opposite sides congruent. Oops. 2y equaled 72x. I noticed right off the bat, but that was using two variables, so I went for 30 equals 150, or x equals 5. And then once I knew x equaled 5, I plugged that in for my x, and I was able to solve for y to be 180. Alright, in example 3, we're going to focus on the property of a parallelogram that the diagonals bisect each other. And you recall, bisecting each other means they cut each other into equal pieces. So for example, if this is 4, then this is 4. And if this is y on that piece of a diagonal, then that's y here. So right off the bat, I am, let's see, maybe not right off the bat. Yeah, here we go. Less obvious is this yellow right triangle. And I know that if it's 17 on the bottom, it's also 17 on the top. And that means I can do the Pythagorean theorem. What I have is 17 for the hypotenuse, I have 8 for this side, and I have x for this side. So I can say x squared plus 8 squared equals 17 squared. Okay, so x squared plus 64 equals 289. We subtract 64 from both sides, so x squared equals 225, or x equals 15. Or perhaps you knew that because you knew an 8, 15, 17 was a Pythagorean triple. Could have saved ourselves some trouble there doing the Pythagorean theorem. Once I know that this side is 15, I know this side is 15, and that can help me to solve for y using this smaller right triangle and the Pythagorean theorem again. This time, let's see, my hypotenuse is y. I have 4 and 15 for the other two sides, so 4 squared plus 15 squared equals y squared. So 16 plus 225 equals y squared. That's 241 equals y squared, or y equals the square root of 241. And 241 is prime. That doesn't break down, and so you're done with that problem. On part B, you go to equal the pieces of the diagonals to each other. X plus 5 equals y plus 2, and 2x plus 3 equals y plus 7. And at this point, perhaps you notice, uh-oh, I've got two different variables. So you might remember a strategy from Algebra 1 called substitution, where you get a variable by itself and plug it back into the other equation. So I'm going to start with equation, I'm going to call these equations 1 and 2. I'm going to start with one equation, the one equation, and I'm going to solve for x. I'm going to get x by itself, so x equals y minus 3. And then remember what you did with that y minus 3 is you took it and you plugged it into the other equation for x, into equation 2. So 2 times y minus 3. And I can do that. I'm just replacing x with y minus 3 plus 3 equals y plus 7. So when I distribute 2y minus 6 plus 3 equals y plus 7, or 2y minus 3 equals y plus 7. Subtract y from both sides, y minus 3 equals 7, or y equals 10. But wait, there's more. We still have to solve for x. So all you're going to do is, now that we know y is 10, plug in 10 for this y here, and x equals 7. Alright, part C, what do we have here? Well, we know if this piece up here is 7, x is automatically 7 because the diagonals bisect each other. They cut each other into equal pieces. What would be the value of y? Well, we have a 30, 60, 90 triangle, it looks like. And so if across from 60 is a whole number, like 7, do you remember that the number across from 30 is then 7 square root 3 over 3? And that was one of the patterns we discovered when we were doing our 30, 60, 90 triangles in the previous chapter. Alright, so I'll let you pause for a U-try. Okay, you should have gotten x to be 8 since the pieces of the diagonal were equal, and then using the 30, 60, 90 triangle here, across from 30 was 8, so y across from 60 would be 8 square root 3. Alright, we're going to actually skip example 4. I think you guys have the hang of the angles, so let's skip that one and go on to the last thing, a little bit of coordinate geometry. So it says to use the slope formula to verify that the opposite sides are indeed parallel. And you might remember the slope formula is this guy, y2 minus y1 over x2 minus x1, and the idea is to show that if they're parallel, they must have the same slope. Alright, so I've already graphed the points for you, luckily. Right off the bat, I noticed that two sides are perfectly vertical, HL and JK. So we could right off the bat say HL and JK, their slopes are undefined. So these are obviously parallel because same slope. I'm going to actually, instead of using the slope formula, I'm going to use something that's a little faster with a graph. I'm going to use rise over run to do HJ and LK. So rise, 1, 2, 3, 4 boxes. I'm sorry, run is 4 boxes. Rise is 1 box. Here we go. Rise is 1 box, 1, 2, 3, 4. And since we're going down, remember that we represent that, what were those, H, J, and LK. We represent those as negative slope. So down 1 over 4, remember. So they did both have a negative 1/4 slope, so they must be parallel because same slope. Alright, and then in this last one, you're supposed to use the midpoint formula to verify that the diagonals bisect each other. So if I were to draw my diagonals on here, they would go from L to J and H to K, and we want to know for sure that they have the same middle point, because if they have the same middle point, they're cutting each other into equal pieces. So we're going to do the midpoint formula for HK. So H and K are the vertices I would use, -1 plus 3 over 2, comma 4 plus -2 over 2. And that does indeed -4 over 2, comma 2 over 2, which would reduce to -2, comma 1. Let's see if the other diagonal, which would be LJ, if she has the same midpoint. Okay, so her coordinates are 3, 3, and -1, -1. And so that gives us 2 over 2, comma 2 over 2, which reduces to 1, 1. Alright, I think I've done something wrong here because they were supposed to come out the same. Let's go back and look at my points. -1 and +3. Silly Miss Benton. So this would have been +2, which would have made this +1. There we go. So the midpoints, same midpoints. Therefore, diagonals bisect each other. Okay, so your homework is a worksheet, and I will see you on Wednesday.